We'll begin this lesson by selecting the geometry icon and then select inch as the desired unit system. In order to create the solid model of the beam, we'll sketch a rectangle on the XY plane and then extrude it 18 inches, followed by selecting Generate. Now that our model is complete, we'll click on the Project tab, followed by clicking on New Simulation to start the simulation module. We next need to change the material to aluminum, so we'll click on Solid in the outline window, followed by clicking on Structural Steel in the Details window, and then select the Import option. On the window that has just opened, we will now click on the radio button next to Aluminum Alloy, followed by selecting the OK button. We'll now set the analysis type to Modal Analysis by clicking on the pull-down menu New Analysis and then select Modal. In order to define the boundary conditions, we'll zoom in on the end of the beam and then use the Face selection tool to select the end of the beam, followed by selecting the pull-down menu options Supports and Fixed Support. We must now specify how many mode shapes we want Workbench to calculate, so we'll click on Analysis Settings in the outline window, and then in the Details window, select the number next to Max Modes Defined and change it to 8. We'll now select Solution in the outline window, followed by selecting the pull-down menu options Deformation and Total, followed by making sure that Mode in the Details window is set to 1. We'll repeat this process of selecting Deformation and Total so that 8 items exist, while setting the corresponding mode to agree with the total deformation number that is listed in the outline window for all 8 of the items. We are now ready to solve the problem, so we'll click on the Solve button. To view the results, we'll select Total Deformation in the outline window and then select the Show Undeformed Wireframe option in the toolbar. As we can see, both on the graphic display and in the Details window, the first natural frequency is calculated to be 7.8246 cycles per second, and the mode shape agrees with what we expected. We can continue to examine other mode shapes and their corresponding natural frequencies by selecting the different total deformation numbers in the outline window.